In this video, we are going to be discussing the example problems related to the drawing of simple Lewis structures or Lewis structures for simple molecules. Definitely check out my previous video where I discuss the steps in detail as to how you would get to draw the structure in the first place. So the first problem is write the Lewis dot structure of carbon monoxide molecule. So CO molecule, that's what we're trying to find out. What is the Lewis dot structure of this particular molecule? So there are different steps that we follow to do this, and I will be following the steps. Again, definitely check out the previous video if you want to learn that again or have a better idea about these steps because I go over them in detail. So the first step is we have to figure out the number of valence electrons. For us to do that, let's write out the outermost configuration for both carbon as well as oxygen. So carbon's outermost configuration is going to be helium 2s2 2p2. Oxygen, on the other hand, is going to be helium. So configuration of helium and then 2s2 2p4. So essentially, oxygen has 6 electrons, whereas carbon has 4 electrons. Okay, that is the total number of electrons for each of these atoms. So the total number of electrons, so total number of valence electrons is going to be equal to 4 plus 6, that's equal to 10 valence electrons. Okay, that's the first step. We figured out the number of valence electrons. The second step is to figure out the central atom. So when I actually mentioned this, when you have to pick the central atom, that's going to be the one which has the lower electronegativity. But in this case, you have only 2 atoms, right? So we can directly jump to the next step, which is figuring out the skeletal structure. So because it has only 2 atoms, it's going to be C and O. This is the skeletal structure of our molecule. Okay, the next one is going to be how do we draw the or the first thing we're going to assume is that they have only a single bond between them, which means they have only one pair of electrons being shared between the two. Okay, so which means you'll have 1, 2. This is the shared electron. Now let's fill in the rest. So 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so this means that, so we've written all the 10 valence electrons. So we finished that. However, notice carbon does not have any, it has only 4 electrons in its outermost shell, whereas the goal is for us to get to 8 electrons for each of the atoms. And that's not happening when it is a single bond. So it doesn't work. Okay, now let's move on to assuming it has a double bond, right? So how we do that is by having 4 electrons between the atoms. Okay, so 4, 5, 6, 7, 8, 9, 10. Oh, actually, I'm sorry. So 7, 8. The reason I did that is because 1, 2, 3, 4, 5, 6, 7, 8. So oxygen's octet is full. Okay, so you have 8 electrons, then the remaining 2 will get added over here. That's also not going to work because the carbon atom is still unhappy. It only has 6 electrons. That would work, right? So this also is a no. The third thing we're going to do is try to do a triple bond. So let's write that, which means there'll be 6 electrons shared, right? And then you have the oxygen, 6, 7, 8, 9, 10. Now the reason I did that was because if you added 2 more electrons, it would be more than 8 electrons for oxygen's octet. Similarly, so if you notice, both carbon as well as oxygen have 8 electrons, which is 1, 2, 3, 4, 5, 6, 7, 8 for the carbon, and then 1, 2, 3, 4, 5, 6, 7, 8 for the oxygen. So this is going to be the Lewis structure for the carbon monoxide, and you'll have 1, 2, 3 bonds, and that's it. Okay, so that's how we do it for carbon monoxide. Next one is slightly tricky, but I'm sure we can figure it out. You have NO3 minus, NO2 minus. It's been a long day. I can't basically see any. So it's NO2 minus the nitrite ion. So the first step we're going to do is figure out the total number of electrons. Okay, now Nitrogen's outermost configuration is going to be helium 2s2 2p3, and oxygen is helium 2s2 2p4. Right. So we know this. We know this about carbon, nitrogen, and oxygen. So the total number of valence electrons will be equal to, for nitrogen, it's 5. For oxygen, it's 6. So 6 plus 5. Okay. This is equal to 6 plus 5, which is, oh, honestly, we should have multiplied the 6 with 2. 6 twos are 18 because you have 2. 6 twos are 18 plus 5, which is equal to, I just noticed that it's given differently in your textbooks. 4, 5, 6, 6. Oh my god, 6 twos are 12. Jeez, sorry. 6 twos are 12 plus 5. And remember, you have an ion over here. It is NO2 minus. So this ion will have a +1 charge. Always remember, when you have a negatively charged ion, which is an anion, you will add a charge. When it's a cation, you will subtract it. So this 12 plus 5 plus 1 gives rise to 18 electrons. Okay. Yeah, 6 twos are 12. I'm sorry. So the second thing you need to do is figure out the central atom, but we've already, here also, if you notice, between nitrogen, you have one atom of nitrogen, two atoms of oxygen. Between nitrogen and oxygen, nitrogen is less electronegative than oxygen, or so because of that, nitrogen will be our central atom. The third step is to draw the skeletal structure. So I'm going to assume the nitrogen is in the center and the oxygen atoms are around it. Okay, the next step will be drawing a single bond between the nitrogen and each of the oxygen atoms. Okay, so you'll have oxygen 1 2, nitrogen 1 2, oxygen. Okay, and then you need 18 electrons. So you have only 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now notice, oxygen is happy, nitrogen is not. Nitrogen only has 6 electrons in its outermost shell. So because of that, it's going to be unhappy. So this is not the answer. So this won't work for us. Okay, so NO does not work. The next thing we're going to do is we're going to try to do 2 bonds. Okay, but instead of trying to do 2 bonds for both the oxygens, we're going to start with trying it with only one of the oxygen atoms. Okay, so let's assume it's the oxygen on the left. Honestly, it could be either, but I just assume that it's on the left. So 1, 2, 3, 4 nitrogen, and let's assume it only has a single bond with this oxygen. Okay, so we have 4 plus 2. 4 plus 2 is equal to 6. So it already has 6 electrons. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now remember, nitrogen, no, oxygen. This oxygen already has 1, 2, 3, 4, 5, 6, 7, 8, and it's happy. So we are left with another pair of electrons which will go onto the nitrogen. This will all have a negative charge. So basically, the molecule is going to be ON, single bond O, with one lone pair of electrons on the nitrogen atom, two lone pairs on this oxygen, and three lone pairs of electrons on this oxygen. And honestly, you could have this be for this oxygen as well. So essentially, it could be the oxygen on the left. It's only thing you need to remember is the fact that both the oxygen atoms cannot have double bonds. Then in that case, nitrogen might have more than 3 bonds, and that won't work. So I hope all of that made sense. In the previous video, definitely, again, check out that video because that'll help a lot with this. And in the next video, we are going to be talking about something called the formal charge.